Hey everyone, howdy, good morning, good afternoon to wherever you're at. Thanks for joining us for unPAC Controls and Building Integration. My name's Eddie and I'm Q-PAC's Media and Engagement Manager. So full transparency from the start, Kurt and I are each broadcasting from home today. I already know that my audio is working, but my video is being a little fussy. So thanks for being patient with us and kind of rolling with the punches. You may hear Kurt's dog bark or my grandpa yell. And if that's the case, just know they both have water and have been walked this afternoon. So everything's good going forward. First things first, AHR is coming up. All of you know that. And if you know anything about us at Q-PAC, it's that we love throwing a pretty sweet party. So this year, Monday, January 22nd, we will be hosting a party at the world famous Shed Aquarium. It's just a hop, skip, and a jump from the McCormick Center where the event will be. Shed Aquarium is pretty cool. It's the first world's freshwater hope spot. And so it does a lot of work with conservation and animals. That being said, we are going to have food, bar, product demos. You'll be able to hang out with the Q-PAC team, and you'll also get to have some drinks with some whales. So come on over. If you want to RSVP for that event, we would love to get a head count. You can either scan the QR code with your phone's camera at the bottom, or you can use that marketing@qpac.com email that's listed at the top. That goes directly to me, and I'll be able to point you in the right direction. So moving on, today we've got Kurt Thomas. So Kurt's been with Q-PAC for 10 years. He's actually one of the first designers and programmers of the original control system for Q-PAC. He likes to say that he's a recovering engineer, and now he's the director of marketing. So he's got a really cool position where he's going to have a lot of information on the history and lineage of the system, as well as what we're iterating on now, and great ways to present it to you, as well as to customers down the line or people that you're working with. So today he will be covering wiring requirements, digital and analog outputs, interlock capabilities and use cases, as well as backnet data overview. And we love when these webinars become conversations. The best way to do that is you can ask questions and engage with us in the chat. I will help Kurt facilitate that. I'll interrupt him whenever I can and kind of spread those questions to him so that he can get them to you. If you have any questions, again, stories, whatever they are, please drop them in the chat. And then at the end, we will also have a dedicated Q&A section so you can ask them if we weren't able to get to them. And then you can also access the entire video on YouTube after the event, and we'll break that down into small pieces so that you can move them to customers or move them throughout your own company as well. So with all that said, I will make way for Kurt and unPAC Controls and Building Integration.
Yeah, thanks for the intro, Eddie. I appreciate it. And I just want to reiterate, please ask questions. So if you have a question about something I'm talking about, or if something I said didn't make sense, you're probably not the only one thinking that. So feel free to post a comment and just let me know what you're thinking about and any questions you have, or like Eddie said, any experiences that you had maybe didn't match up with what I'm saying. So feel free to call me out. So let's start with the product overview. So just in case there are folks on here that are not that familiar with our product, I'm going to start with just what do we do? What are the actual aspects of the control side of our fan system? So we say that there are two main components to our fan system. We have our control panel, and you can take 208 volt 3-phase or 460 volt 3-phase. It is backnet compatible. There is an HMI on the front. It comes with an HOA switch and it's a disconnect, and it connects to what we call our smart fan. Our smart fan being up to 1 to 9 fans. It connects to our quick connect box, and the control panel connects to our quick connect box. It contains harnesses and our bulkhead wall. So the reason we're calling it a smart fan is because if you are an electrical, or if you're an electrician, right, and you're installing something in the field, a fan in the field or Baldor motor, then you run one run of power controls, right? So that's the exact same thing with our system. I think it's a little misleading for an electrician to say, oh, I've got to wire up 9 fans, when really it's just one run of power and controls. So we call it the plethora of fans a smart fan. It's a total package. All right, so here is a picture of our quick start wiring guide. So if you have if you ever have any questions or need a reference for our control side, this is where you would reference. So the quick start wiring guide has everything you need to know. The big box, the labeled control panel, that is everywhere you connect to all the wires going in and out of that control panel. So anywhere you see a dotted line that crosses that box, that's where you're going to run a line in the field. Not all of them are required. So we'll kind of talk about some of the things that you may need in the field and some of the information you need. A lot of these are just output data. What is required, however, is connecting the control panel to the quick connect box. So that smaller box over there on the right, that is our quick connect box. And so for our premium control package, you will need 4 wires for power, three phases for your power, and then 1 ground, and then an 8 conductor wire for the controls. All right. So let's start with the quick connect box. Our patented quick connect box is, in my opinion, the thing that makes our product so great. It makes everything plug and play. Everything goes back to a single location. All of the power wires and plugs and control plugs, and even the tubing. You just plug it into our quick connect box, and then you don't have to run a million home runs of power and control all the way back to our external control panel, which may be right next to the unit, or it may be down the hallway in another room or your facility room, your controls room, right? So everything's pretty self-explanatory. I think we have 4 knockouts, 2 on the top, 2 on the bottom. You'd need to run your power and your controls in separate conduit. If you don't, then you may have some noise on some of those control wires just through induction. So we do recommend running 2 runs of conduit, 1 for power and 1 from controls. It doesn't matter how many fans you have in your system. It's just 1 run of power and 1 run of controls, which makes it a lot easier on your electrician. So if they quote you for a full day's worth of work, then you can tell them that I said that that's not true. It should only take them a couple hours. So like I mentioned earlier, connecting between the control panel and quick connect box, 8 conductor wire, use separate conduit. You can use any type of control wire you typically have on your truck, right? It can be anywhere from, I don't know, I think 14 gauge up to 22 gauge. It doesn't have to be shielded. If you want to shield it, that's fine. Just make sure you don't ground the shielding at both sides, right? Make sure you ground it at one end so you reduce any of that inductance. But it's really that simple. For the basic controller or basic quick connect box, again, basic, if you get a basic package, you will not get the HMI and the PLC, but you still will get an HOA switch and a potentiometer and your disconnect switch. It's just going to be a lot more limited as far as controls. So with the basic, you would run a 6 conductor wire. All right, so in order to control the speed of your fans, we have 3 options. We have several options, but at the very front of your control panel, like I mentioned, you have an HOA switch. You have hand, off, and auto. Off is exactly as it sounds. Your system's not going to run. Your fans are not going to turn. It can still have power. You can still communicate to it via BACnet. The BACnet is just going to tell you that your fans are off. Hand mode. So hand mode, I think, is a really great design and a great feature of our control panel. So if you are in a critical application, you're in a hospital and you're like, I can never be down. Like if the BACnet system goes down, or if my BAS goes down, like I need a way to run the fans. Hand mode is that option. You can literally take our PLC, hit it with a hammer, pull it out of our control panel, and if you switch it to hand mode and turn that potentiometer, your fans are still going to run. So it is a hard bypass. If you do put it in hand mode, you are going to bypass several features, right? Since we are bypassing that PLC, that means that your Fireman Override is going to be bypassed, your Interlock is going to be bypassed, any delays that you have set up will no longer function in hand mode. So it's purely, hey, I'm going to put it in hand mode, bypass everything, and turn that potentiometer to get the fans running. There is one thing it does not bypass, however, and that is your safety circuit. So if you have your high stat, low stat, any type of safety sensors, hand mode will shut off, or your fans will shut off if any of those sensors trip. So just know that. And we'll talk more about the safety sensor or the safety circuit a little bit later. All right, so in auto mode, there are 4 different ways to control the speed of our fans. So 4 different speed controls. One is a 0 to 10 VDC, right? I think most people are familiar with that. That is the most common. I would say that our fans are controlled through that 0 to 10 at least 90% of the time. So the standard setup is for your controls contractor and your building automation system to monitor the static pressure 2/3 the way down the ductwork. And then they just modulate that 0 to 10 volt signal that they send to our fans to ramp them up and down to make sure they're maintaining that duct static pressure. That's the most common use. Constant CFM. If you have an application where you need to ensure that a certain amount of air is moving, then we can do that. You don't need to connect it to your BAS. You can type into the HMI or via BACnet and say, hey, I need you to run or move this much air, and we will ramp the fans up and down to maintain that. You will, however, need to calibrate your PID constants. So you want to make sure that your fans aren't ramping up too fast or too slow, and whenever they hit the set point, that they are running at a stable speed and not overshooting and undershooting, right? So this mode is most commonly used from what I've seen in hospitals on return arrays. So hospitals have very strict requirements on how many air changes per hour they need. And so they will set the return fans to match whatever requirements they need and make sure they're exhausting enough air out of their building to maintain the correct air changes per hour. And then they'll just set the supply fan to make sure that it's maintaining the static pressure. All right, so another option is constant static. So if you have a critical application where you don't think that your BAS is very reliable, or maybe you don't have a BAS yet, and you want to make sure you want to maintain duct static pressure, then you can tie in a static pressure sensor 2/3 of the way down the duct, at the end of the duct, wherever you want. As long as it has an output of 0 to 10 volts, you can tie it back to our control panel. And then again, set the constants on the PID loop so that it ramps up and down at the correct rate. But we can maintain your duct static pressure for you. And the final way is for BACnet. So I only suggest using BACnet speed control for non-critical applications. So because if your BACnet network does go down, then our fans are going to continue to run at the last speed signal they were given. And then if you have a power cycle, then they won't run at all. So as long as your BACnet network is in good shape, you can send a signal to our fans and we will modulate up and down. Right. Digital and analog outputs. So we have a lot of outputs. So if you first of all, you can monitor everything via BACnet, right? But if you don't have BACnet or you want a double system, sorry, let's go. Sheldon, constant CFM is a differential pressure transmitter required. No, we actually provide that pressure transducer in our Quick Connect box. So we are monitoring CFM at all times, whether you use constant CFM mode or not. And we pass that information along via BACnet. So. All right, analog and digital feedback. So if you want more feedback than just what you can get via BACnet, then you can use these digital and analog outputs. So if you want to monitor airflow, then we do have an analog output. It outputs a 0 to 10 volt signal. But depending on the actual system you order, you can look in our HMI and it'll tell you what the high end is. So the low end's obviously 0 CFM. The high end will tell you in the HMI, and then it's just a linear progression up there. So if you get 5 volts, then it's going to be half of the CFM between 0 and that high value that we give you in the HMI. No difficult calculations there, just interpolating. Then we have some digital outputs. We have relay 1, which is just, sorry, my dog is, come here, buddy. He's getting a little uppity. He's probably bored, but RO1, ready state. So just saying, hey, your fan array is ready and operational. It doesn't necessarily mean that your fans are running. It's just saying, hey, your safety circuit is closed, your enable disable switch is enabled, start stop is in start, and your HOA switch is set in auto. So your fans are ready to operate and they may be operating. So relay number 2, this is used to say, hey, you have fans that are actually spinning. You are moving air. The reason we added this is because So a lot of folks are used to having, you know, VFDs and AC motors, right? And so you can send your VFD a signal, but you don't always know if the motor is actually spinning or not, right? So they would add CTs to that motor and the power wire going into that motor. Um, so we said, hey, you don't have to do that with ours. We'll tell you, we'll give you a relay, monitor that relay. You don't have to put a bunch of CTs on every single fan just to prove it's running. We give you that information. So relay number 3, it's just a binary output. It's saying, hey, you don't have any errors with your system, or you do. So if it's closed, then everything's operating nominally. And if it's open, then you have at least one error. If you're not monitoring that error via BACnet, then you can go to the HMI and see exactly what that error is. Safety circuit. So typical operation, right? So there are a lot of different reasons, or a lot of different sensors for your safety circuit, right? You don't necessarily need all of them, but the common ones are high stat, low stat, and freeze stat. So if you want to make sure that you're not blowing out any ductwork, crumpling any ductwork upstream, or if you want to make sure your fans are not operating whenever your coil has frozen over, then you can add those in series. Please add them in series and not parallel. I have seen that happen. If you're afraid that you have, you know, your facility folks, whenever they might touch a blade or harm themselves, you know, then you can add a door switch. The safety circuit is a hard safety circuit, meaning it kills power to the fan. So we have a contactor in our control panel. If that safety circuit trips, then the fans do not have power. So that is the reason hand mode does not work with the safety circuit trips. You may want to bypass our safety circuit if you're just starting it up, starting our system, and you want to do a bump test and you've got power, then you can put a wire in between 24 VDC and digital input 1, and that'll bypass the safety circuit, and you can just put it in hand mode. That's a really common method every time things are after an install, just to do a bump test. Let's see, Doug, I got a question. Relay 3 will tell you which fan has failed, or just that a fan has failed. It just tells you, it's just a binary output. It's just going to say you have an error. So it may not be a fan. You may have a high voltage alarm. You may have a low voltage alarm, or maybe it's reading an odd CFM that it thinks is incorrect, or it's not receiving a CFM signal. Could be anything, or it could be a failed fan. So it's just saying, hey, you have at least one error. And then you can go to the HMI and hit the flashing alarm button, and it'll tell you exactly what that alarm is. So. All right, start, stop. So digital input 2. This is just a binary signal from your building automation system saying, hey, I want you to run. So there are 2 things you need from hey, Frank, I see your question. I'll get to BACnet pretty shortly. So there are 2 things we need from your building automation system. We need a speed control, and we need a start signal. So again, if you want to bypass this and put a jumper in, you can. And then just whenever you don't want the fans to run, and your BS can just send a 0-volt signal. But it is pretty common for start, stop, and a 0 to 10-volt signal to be used. And it's pretty basic. But hand mode does bypass it. So if you're in hand mode, then it's not going to look for that start signal from your BAS. So hand mode, like I said, bypasses everything and bypasses our internal PLC. We don't want any errors with our PLC or anything to stop you from actually operating these fans. Interlock. So I think our interlock function actually works very well. I think it's best for critical applications. That way you don't have to rely on your building automation system to make sure that a damper is open before we turn the fan, so you don't blow out any blades, right? If you want to, so this is how it functions. With RO1, which is the ready operational relay we talked about earlier, if everything's ready, we get a start signal, your building automation system's calling for air, then we will then provide power through RO1C and RO1A, right? We'll provide power to your damper actuator. And then once your dampers are fully open, which may take 5 seconds, may take 60 seconds, some dampers are operate at different speeds, then the end switch will be made and it'll close the circuit between 24V and DI3. When that happens, then our fans will actually start to spin. So the interlock is disabled by default. So if you do want to use it, make sure you go into the HMI and enable it for use. And we will control dampers for you. So I think it's a great feature. You don't have to rely on the controls contractor to set that functionality up with the building automation system and their controls. It can just be handled locally, and which I think is best, because if you do have a failure, then we continue to operate as long as we have power. All right, Fireman Override. So first of all, what is Fireman Override and when would you use it? Fireman Override is not commonly used, but there are times when you absolutely have to have it. It's most common in large buildings. So if there is a fire, then in large skyscrapers, then there's a cubby that the firemen run to, a little control station, and they can override access to the HVAC system and specifically to our fans, right? So if our fans are feeding, say, a stairwell, and there's a fire, then you want to make sure that the fans are running and moving as much air in that stairwell as possible. You want the folks that are exiting the building to be able to breathe and to continue to have oxygen. If our fans are feeding some of the top floors that may be on fire, you probably want our fans to shut off so that you can help choke out that fire so you don't continue to feed it with fresh oxygen. So these are all preset settings. And the fireman can switch a switch and toggle our system to go into Fireman Override, and we'll do whatever was preset. So if you want us to go to 0 speed, then we'll shut down the fans and we'll throw an alarm and say, hey, we're in Fireman Override. We can go to a set speed. So if you say, hey, I don't want you to run 100%, but I want you to run 60% or 80%, in the event that Fireman Override is enabled, then we can do that. We can just continue to operate normally. So you can actually create another bypass. If you want the firemen to actually control the speed, they can give a 0 to 10 if they want. So if you want to add a relay and for us to continue to operate normally and run off of a 0 to 10, then we can do that as well. Or we can do control type set. So if you're running off of a 0 to 10 and you want us to switch control modes, say to maintain duct static pressure, then we can do that as well. So when Fireman Override is enabled, we will change the control mode to duct static pressure and make sure that we're not relying on the building automation system to maintain that duct static pressure. All right. BACnet. Here we go, Frank. So normal operation or normal structure of the building automation system protocols are the field components, right? And those are here all at the bottom in the red box. We fall in that field. We are a component. Right now, we communicate via BACnet MSTP. IP is becoming more and more popular, and it is on our roadmap. I expect us to have it by the end of 2024. But if you need it, then we have another solution for you. We can send you a link to another device that can convert MSTP to BACnet IP. So I think it's like a couple $100, and we don't actually sell it. We don't mark it up or anything. We just take you directly to the site where you can buy it. So. Yeah, so you have all of your devices down below in the field, your digital and your analog, your MSTP, whether it's BACnet or whether it's Modbus, and then they feed the building automation system controllers and PLCs, right? So that's where all the logic is done. That's where your controls contractors will spend a lot of time making sure everything's balanced, creating the touch points that the actual management team will need to use. So if they need to change the speed of the fans or change set points, then they can do that in the management level, where you connect all of your HMIs and everything. So that's your typical stack for, and it's a pretty simplified version of your building automation system. So our BACnet list, we provide quite a lot of information. The fan speed. So this is an actual feedback. This isn't saying, this is what you're telling us to run. This is actually what the fans are running at. Analog input, so the amount of airflow. So like I mentioned earlier, we do have a pressure transducer in our quick connect box, and it measures the differential pressure between the velocity pressure at the throat of the fan versus the upstream pressure. And then we can use some of Bernoulli's equations to calculate the airflow. And we pass that information along through analog input 1. We tell you what the power consumption is in watts, what the voltage is. It goes all the way up to 32,000. So if you ever see that, then you definitely have a bigger issue. But typically, it won't go above 480 or 500, right? Current reading. So we also tell you how much current is being drawn through our entire system. That's not just our fans, but that is right at the input of the control panel. We have a CT sensor there. So it'll take into account our power, our power supply, and the PLC and any other smaller components that are drawing power. Analog value 0, that'll tell you. So that's actually where you send the speak signal if you want to control the fans via backnet without running an extra 0 to 10 volt wire. AV1, so that's your set point. If you want to change your set point via backnet, if you're operating in constant airflow mode, and then constant static pressure mode. If you want to change, which you should, and they should be set once you figure out what you want them to be. But you do have the option to change the static pressure set point via backnet. Interlock status. So we tell you if you're using the interlock to control your dampers or to do like a lead lag with a return and supply fan, then that'll tell you the status of the interlock. We'll tell you the status of the Fireman Override. We give you a system status, which I'll talk more about later, and integrator status. So integrators, they're quick connect boxes. So do you have an error with your quick connect box? What's the status of it? Most of the time, you're just going to have one quick connect box. If you have more than 9 fans, then you may have 2. Anything more than 18 fans, you may have an integrator C or an integrator D. The control type. So like we talked about earlier, control types are 0 to 10, constant static, constant CFM, or backnet. So that'll tell you what control type you're in, and you can even dictate it there via backnet if you would like. And then the binary values. So system runs, you can enable, disable the system via backnet. There's an interlock toggle, and then binary value 3, 4, and on tells you what the status is of that particular fan. So we do give you individual fan status, and you can see the dots down below. That goes integrator A fan 1, integrator fan 2, all the way down to 9, and then it'll go down to integrator B fan 1, fan 2, and so on. So that's where you can monitor individual fan status. All right, alarms and system status. So what happens whenever you have an alarm? There are 4 things that happen really. RO3, that relay number 3 opens. So that's a binary output that says, hey, something's wrong. It doesn't tell you exactly what's wrong, but it gives you an indicator that you have an error somewhere in the system. The second thing that happens is alarm information is sent to the BAS via backnet. So it's going to tell you exactly what the issue is. You'll see it in your system status. You'll see it if there's a fan alarm or an integrator alarm. One of those are going to light up and say, hey, something's wrong here. The HMI on the front of the control panel, there's going to be an audible alarm. It's going to make a high frequency buzzing alarm. So if you're around, you'll be able to hear it. And then the HMI is also going to flash, and there's going to be a button that flashes. And whenever you hit that button, this screen is going to show up, and it's just going to list all of the active alarms. So the alarm on this example alarm description is saying, hey, code 1000, and that is a safety circuit alarm. So that's just saying, hey, one of your safety sensors has tripped, and we are in safe mode. We are not running the fans. The fans don't even have power. So fix that safety circuit before we can run. So the alarm breakdown. So these are all the alarms that you will see at the display or via backnet. So your safety circuit is triggered, right? We just talked about that. If you have a power meter that's not responding. Craig White is asking, what's the purpose of the interlock toggle? So the interlock toggle basically just says it's turning the functionality on or not, right? So if you want to use the interlock, then you can enable it for use at the HMI, or you can enable it for use via BACnet. So once it's set, it's usually set, and you don't toggle it on and off. I can't think of a reason to toggle it on and off, but there's 2 different ways to turn it on. So thanks for your question. Power meter is not responding. So we have a power meter. If you see code 1001 show up, you may also see code 1004. That doesn't mean that your fans are not operating. That just means that, hey, our meter that monitors voltage, current, and power consumption, something's going on. Our PLC is not able to communicate with it. And basically, you need to check the wire between it. It does communicate. That device does communicate via Modbus to our PLC. And so, yeah, you just need to basically check the wiring. And if there is a light on it, and if that light is green, then it's functioning properly. It's probably wiring. And if it's off, then you may need to do a new sensor. So they're really easy to swap out, and it's not a common issue. But just know that your fans will still operate, and it's not a critical failure. If you do have a voltage alarm, then you have something wrong, likely with the voltage. Maybe you have super low voltage or super high voltage. Anything outside of, if you have a 460 volt system or 480 volt system, anything below 440 is going to throw an alarm. Anything above 500 is going to throw an alarm. And then for 200 to 240 volt system, anything below 190 and anything above 250 volt is going to throw an alarm. Current alarm, if you have some weird current patterns that go beyond what you should be getting, then that alarm will throw. The EEPROM variable. So this is, again, not a very common alarm, but if that alarm does occur, then it's actually a really simple fix. You just have to call our technical support team, and they will give you a code to go into the back end and change some settings. So it just means that something happened with the memory of the PLC, and it doesn't remember how many integrators or how many fans or the fan model. I don't really know why that would ever occurs, but it does occasionally occur, but not very often. Alarms at the integrator. So if you have an integrator A alarm, fault at integrator A, that just means that, yeah, you may have an issue with the printed circuit board or some wiring inside of our control panel. It kind of it goes along with the quick connect box PCB alarm. You might see those in conjunction. So whenever that happens, it might mean that you just have a loose pin somewhere between the quick connect box and the fan. So really, to fix that, a lot of times you just need to follow the wires between the quick connect box and the fan itself. Just kind of take them apart, make sure the pins are in the plug snug, and whenever you push it in, the pins aren't falling out the back, right? So just make sure everything's nice and snug. If that doesn't work, then you may have to open up the quick connect box one additional layer just to make sure that the wire from the plug at the quick connect box is snug on the printed circuit board. So pressure transducer alarm, that has been disabled just basically because there were too many nuisance alarms. We're still working on tuning that one up. And then quick connect A PCB alarm. Yeah, we went over that. So. All right, system status. System status is super underrated in my opinion. So whenever you're doing a startup or whenever you have an issue, this is the first thing I check. Whenever I was running technical support, this is the first thing I would ask. What's the status? What's the system status say? So it's just a really quick way to diagnose what's going on with the system. It'll tell you your safety circuit's tripped. Maybe your HOA is in the off position. You're in hand mode. Fireman Override. It'll tell you whatever mode you're in will be displayed there on the HMI. It's also displayed via BACnet. So I always look at this first. It's super simple. It only show one at a time. So in descending order, right? So if your safety circuit's tripped, that's going to be the highest priority. And if multiple things are tripped, only the highest priority one's going to show. But yeah, it's super easy to diagnose our system whenever you have that. So if you're doing startup and you don't understand why it's not running, more than likely your answer is going to be looking at this system status. So. All right, and I wanted to give a sneak peek. Our controls team and engineering team have been cleaning things up and making things a whole lot simpler. So I don't know, I was super proud whenever they shared this picture. This may be coming in 2024. Not sure if the color will stick. I love the color, by the way, but the internal components are what I'm super excited about. Super clean, and they've made it super obvious where you need to connect your wires to. So they're down there at the very bottom on that picture on the left. You can kind of see some terminal blocks that are isolated. That's what you use to connect to the quick connect box. So it's super easy to see what terminals you need to connect to without being in the mess of the rest of them. So I don't know, super proud of the team. They got the controller all the way up there at the top to make room for connecting everything down at the bottom. So.
Not that we're paying 10 or 15 cents a stand. Right. No, I agree.
Anybody have any questions?
Yeah, perfect time for questions. Also, something that we do on our end is we always assume that you know some things and don't know some things, but we never know exactly what that is. So something I'll add right here, this is actually a PDF that highlights our control package and the options. A great way, little one pager for you all to have just for your own benefit, as well as sharing with customers or people who are learning the Q-PAC system. We know that there are a lot of new reps jumping on board, a lot of new contractors working with our stuff. So these are just great little info packets that we can, I can actually send out to you today. So we usually do a follow-up survey to see what kind of information you all liked and didn't like, things we can do better in the future. I can include this one pager as well as some of the pertinent information that Kurt presented today. So yeah, now's a great time for you to ask any questions, take a look at that control package option for you if that's of any relevance, and we'll hang out for a few minutes and be here to answer any questions that you have.
Yeah, thanks for your question, Richard. The panel size is based on, it's based on integrator size. So it does have a little bit to do with how many fans, but mostly it's based on the amp draw. So we have a 30 amp panel, 30 amp and below, 60 amp and below, 100 amp and below, and 200 amp and below. And then anything above 200 amps, we can do. It's just a custom, but our standards, we have 4 standard control panels, and it's based on amp draw. Yeah, and so Eddie, can you bring up the slide with our event there in Chicago? So if you have any more questions, feel free to post them and I'll get back to them. So everybody wasn't here at the very beginning, so I just want to make sure you all see this. We are going to have an event at the Shed Aquarium at AHR on January 22nd between 6 p.m. and 10 p.m. Everybody here is invited, so it's going to be really cool to hang out with the whales. We'll do a product demonstration, actually do a physical install, so you can see how to install a Q-PAC fan array and an air handler. Yeah, so super excited to see you guys. Please register. You can use that QR code in the bottom right to register for it.
Right. Yeah. Use the QR code, or if that doesn't work for you, not something that you're really in tune with doing, please email me directly at marketing@qpac.com. We do have limited spaces there, so we really would like to keep a head count. The cool part is they're shutting down the whole aquarium for us. So starting at that 6 p.m., you will actually be able to tour parts of the facility. You'll be able to go around and like we said, have some drinks with some whales, which will be pretty cool.
All right, thanks for your question, Chun. Let's see. Siemens BACnet MST, COM, current, and kilowatt readings are not matching with the HMI reading. According to Siemens Tech, they're just polling whatever the BACnet are exporting. I'd love to dive into that with you. And yeah, actually, I'm going to post my phone number in the chat. And if you want to send me some pictures, then that would be really cool. I want to see exactly what you're looking at. Comparing the Siemens ratings with ours, and actually where you actually installed the Siemens controller and what you're comparing with. So, and if I can't answer it, then I'll definitely get you to my technical support team. Yeah, thanks, Craig. I really like it too. It's cleans things up, and most importantly, it gives some more room there at the bottom, so you're not as crammed with all the wires going in and out. So.
Yeah, we'll hang out for another minute or so. And again, if we will have a follow-up survey coming out to you. So if you have any questions, we always leave an option there for you to ask. Sometimes you might think of it later. And again, marketing@qpac.com. Again, that goes straight to me. I can get in touch with Kurt immediately. All of you can now as well. He just put his phone number on the internet. So if you want to invite him to a family Christmas party or ask him about MSTP, feel free to call him, text him. He loves those, especially early in the morning when he's up with his baby. So if you have a 3 a.m. question, ask Kurt. He's probably the perfect guy to ask.
I'll probably be up.
Yeah, like we said, we'll wait about another minute. And all of this information will be posted again to YouTube. The entire presentation will be presented there we'll put it in a little playlist. And then usually what I'll do is I'll go back through and I'll break it down into smaller chunks, little 1, 2, 3 minute videos for you and for your edification. If you want to share it with anybody who has these same questions. And again, please always reach out to us. We're happy to engage in any level, in any way that you all need to better understand kind of what's going on. So.
Yeah, sure thing, John.
Cool. Well, looks like nothing else is coming down the pipeline. So we really appreciate you all joining us today. We will look forward to doing something like this near the end of December again. Part of that feedback that we'll get from you are topics that you're interested in seeing in a month. And we would love to engage with you on anything new and anything you're interested in.
Yeah, absolutely.
Yeah, David.
You got my phone number. Send them to me, and if I can't answer them, then I'll get you in contact with my support team. I'd love to learn more about that issue. I think I can't remember. I've been to Milwaukee, but it's been several years ago. So I'm curious to know if that's one that I dealt with a long time ago, like 6 years ago or something, or if it's something new. So yeah, that's awesome. All right, thanks for your number, David.
All right, you all, thanks. Happy holidays, and we'll see you in a few weeks. See you, John.
See y'all.